Hello everyone, we are RU Tutored. Our group consists of Brittney, Charlie, Muhammed, and myself, Deborah. As you may already know, Rutgers.edu provides tutoring to its students. Its students make online requests for a tutor and then wait until they are matched. The matching process is currently done manually, so it can be quite lengthy and take up to 2 weeks to conclude. A student's requests may also be denied due to a lack of tutors available for the course. Once the student is matched to a tutor, he or she will receive tutoring once a week for an hour, and it may take a few weeks for the tutor to truly understand their tutor's misconceptions. Tutoring can be extremely helpful in one's learning. The graph shows that students who receive one-on-one tutoring using a mastery learning technique score 2 standard deviations higher than others. So we believe that by improving the SOE tutoring system, we can reach more students and have a deeper impact in their learning. A chain is only as strong as its weakest link. So we want to create a comprehensive system that provides tools to all parties, tutors, and faculty. Our solution consists of 3 main aspects: matching students to tutors instantaneously based on their course and their availability, forecasting the demand for weekly tutor hours to help faculty planning, and a dynamic conceptual inventory survey that will be used as mastery learning technique to give tutors insights on their tutors' misconceptions.
Currently, there are 2 main types of peer tutoring products in the market. One being marketed to students and the other to colleges. GoPeer is a college independent platform where students can create profiles and pay all the fee through the app to receive tutoring sessions with both online and in-person options. PenG, on the other hand, is a college-based application where you log in with your school ID, schedule meetings with tutors and tutors at your institution, and chat with them. At RU Tutored, we're not just matching students with tutors like the products we mentioned in the previous slide, but also we provide tools for both tutors and faculty members. Now, what do we mean by that? Forecasting models were created to help aid faculty members in the hiring process. Additionally, by having students take conceptual inventory surveys, we're not only able to help tutors better understand what topics may be causing students' misconceptions. R2.com is dynamic, which means the outputs differ based on the user inputs. To accomplish this, we use CSS for styling, JavaScript to increase user engagement, MySQL to store information on our database, PHP to communicate with the database. There are many resource limitations, such as the learning center's operating hours and each tutor's maximum availability to work. To tackle this issue, we use heuristics to solve a nonlinear mixed integer programming optimization problem, as seen on the right, where the goal is to minimize the number of tutors employed while meeting the demand and resource constraints. We have acquired 10 semesters of data and fit a generalized linear regression model to the semester number versus natural logarithm of total hours, and got an equation as shown on the right. When we input the next semester to the equation and so for total hours, we got 308 hours per week.
Since there were many courses requested, we used stepwise regression to eliminate courses that are not statistically significant to total hours. The 8 courses that remained in the model after the analysis is shown below. Based on the results of the stepwise regression, we forecasted the demand for each statistically significant course using generalized linear regression. A model for both the spring and fall semesters were made for each course to better predict the demand, as some courses are only offered in certain semesters. And an example of this is the General Chemistry for Engineers 2 course. This course is typically taken in the spring, which is why our model's predicted demand for fall 2020 is 0. To ensure the models discussed were accurate, we reviewed accuracy measures such as the root mean square error for each model. For example, the root mean square error of the model created for total demand is 0.28. Furthermore, we checked the observed versus the predicted for each semester. The graph to the right shows the observed total hours for each semester in blue and the predicted values in gray. As mentioned, Bloom found that students who received one-on-one tutoring using mastery learning techniques performed significantly better. For that reason, we want to integrate a mastery learning technique into our project. Conceptual inventory surveys are used to help instructors understand what their students aren't understanding. The table to the right shows the results of a study where students' confidence and their score on a conceptual inventory survey was compared. As the table shows, students tend to under and overestimate their understanding on topics, which is why it's so important to have a tool in place that objectively gauges understanding. Knowing the benefits mastery learning techniques can have in tutoring, we decided to create a dynamic conceptual inventory survey specific to the Physics 123 course offered at Rutgers. The steps used to create this survey are listed below. Essentially, we made sure our survey included questions that test students on the topics and types of knowledge required to pass Physics 123. We then created a dynamic algorithm that our website follows, so different questions are displayed based on the students' answers. Charlie will now go into further detail on how we validated that the survey we created accurately gauges physics knowledge.
For testing and validation of our survey, we selected people with various knowledge of physics. Ideally, a well-constructed survey would show a positive linear relationship between the number of physics courses and the scores of our participants. Our testing resulted in an R-square value of 0.76, meaning there's a fairly strong relationship between prior physics courses taken and scores on our survey. So here we have a demonstration of the intended use of RU Tutored using the 3 parties involved. To start off, we take the perspective of the tutor. Here they are logging in and they're going to go to their schedule where they could select the maximum number of hours to work per week. And here they had a schedule beforehand, so they are here adjusting it. And then once they go to courses, they could select the courses they are eligible to tutor in. So now we switch gears to the tutie's perspective, and here they are logging in. So under the Find a Tutor tab, they could select the course they want to be tutored in and adjust their schedule accordingly. So once that is submitted, they could click on the Show Tutors options and see all the tutors that match their preferences. Here the tutor could select a tutor and they could select the day and the time for their tutoring session. Once submitted, they are prompted to take the survey of the course they selected, which in this case is Physics 123. With the survey completed, the tutor can now view the survey results, and with that result, they could improve the tutoring process once they go ahead and meet each other. And now they are capable of identifying the misconceptions the tutee may have. So now to showcase how the faculty can use the website, here they are logging in, and they have a table of all the finalized matches. And along with that table, they have a dashboard of various forecasting models that can be used for preparation of the upcoming semesters. To share, for our project management, we shared responsibilities. We had leads for each task. Leads were responsible for distributing tasks to others and communicating progress. We met regularly and created due dates for ourselves to ensure progress is being made so that our project can be completed on time. For our risk, there is limited time to validate the conceptual inventory survey as they can take years to be validated. To mitigate the risk, we selected a wide range of people to complete the survey to ensure the results are accurate. Another risk would be the accuracy of the forecasting models because of the lack of detailed data. But as more data is collected, the models can be adjusted to improve accuracy. In conclusion, RU Tutored seeks to improve the tutoring process for tutees, tutors, and faculty involved. Not only does RU Tutor help match students to tutors, but also helps tutors understand what topics their tutees haven't mastered and improves the planning process for faculty. Ultimately, the goal of RU Tutor is to teach students, inform tutors, and improve planning. Before wrapping things up, we would like to give a special thanks to our advisors, Dr. Fan and Joseph Olson, and we'd also like to thank Yufei and Dr. Jafar for their help along the way. Thank you for listening to our presentation. We will gladly answer any questions.